My name's Bob Jones. I was with Parker for 42 years, starting back in 1964, retiring in 2006. And I was started as an engineer, worked design engineer, a lot of stuff for preliminary design, that stuff, marketing manager, and I became the general manager of the Air and Space Division for many years, and then later the Hydraulics Division before I retired. So we were very lucky, Bill, to live in this exciting time of aerospace, really.
That's right.
And it was not like the red tape. It took forever to get things done. You could just go do them. As Bill described with what Bill did on Apollo, we had to act very, very quickly. So we got things done. We were very active in the space program, from the Saturn and the Apollo onto the shuttle, satellite controls, Viking programs. And as a matter of fact, out of the Viking program, we developed miniaturized valves that created a biomedical division for Parker many years ago.
My name is Bill Swift. I started with Parker in 1963, so before Bob. And I came out of school as an engineer. I thought I was going to fix the world. My title was design engineer. But most of my early career was involved with making Parker hardware work, working with the technicians in the laboratory, getting the qualification test program for all these space programs done. Saturn spacecraft, we built a flow control valve that provided fuel to the engine. And it was a big stainless steel device, 6-inch bore, I believe. And the problem you had at that time was, how do you test this thing? We had no facility that could develop that kind of flow rate. So you might remember a guy by the name of Dick Greeter. Remember him? Mm-hmm. He designed a computer, basically, that allowed us to hook that valve up to a electronic device that would simulate the flow of the valve by putting a torque on the butterfly. It was very advanced. I mean, the thing was the size of a desk. Now today you would do it with a laptop. But it was really, really interesting. That was my first thing out of school. I thought, this is great stuff. We provided many different types of valves for Apollo, but they were primarily all pneumatic valves of one sort or another. There were a few fuel valves thrown in, but fuel valves at that time were strange. They were not standard fuels. They were hypergolic fuels, hydrazine and nitrous N2O4. And put them together and they combust. Well, it's kind of hard to test that kind of a system too. So we had to develop a test facility that would allow us to do that. But all the other valves were standard pneumatic valves, regulators, relief valves, burst diaphragms, that type of device that were required for Apollo. The difference being they were pretty much smaller than your standard aircraft valve designs. Had to keep the weight down. Regulators were, I think, the most common type of device we built. They were the most complex, so it took a lot more effort to get those through the development program. We had 120 pieces of hardware on Apollo. There were maybe 17 different designs, different types of valves. Still a lot of effort.
Because when the Apollo program, the manned space program was there, we didn't ever send one to space before, so we were concerned about leakage. We were using helium gas that would leak. Hydrogen gas is part of the propellant that would leak. We didn't use forgings or castings. We machined everything right out of pieces of metal. And we didn't use, O-rings and bolts to tie them together. We welded these things together. So you imagine how critical it had to be to work, that if you ever had to replace it, you had to cut the weld open to take the part apart. That was the criticality of what we were going through. Weight was very, very important because, every pound you take up, there's another many, many pounds of thrust required. And precision was important because you only had limited supplies of oxygen and hydrogen and helium, so that you couldn't waste it. You had to be very precise and how they were made. We used things, Belvilles and bellows, because the bellows isolated the internal fluids, it didn't leak. The bellows were frictionless and can make them do some strange characteristics, negative spring rates and things like that. So we used to joke, actually, we said every product had bellows, Belvilles, and boo-boos. These products were very advanced, took a lot of time to make, they were expensive, and as Bill has said, they had to go through some extreme testing. You had very high vibration loads when you're on the launch vehicles. You had temperature extremes when you're out in space. So all this stuff had to be thermally compensated, and they were a pretty precise piece of equipment.
The facilities that were built for testing were in remote areas. We went to a place called Newhall. It's northeast of Los Angeles, out in the middle of nowhere. And we actually built simple facilities to test these valves that were very, very dangerous pieces of equipment. Now you think you send your people out there and you need to be pretty careful. You don't want to hurt them either. The reason why we're testing out there is because the fuels that we're using were very corrosive, and you couldn't have them around the normal environment.
Yeah, those days, I mean, this was a thing the nation was trying to achieve, so there was enormous excitement about it. Obviously, amongst the Parker people, because you wanted to be the first one to do everything, get everything right. So there was enormous excitement and thrill about this stuff. There was a lot of money being put into the program because it was being supported by their government to do this, to land somebody by the 69s.
I think we trained a lot of people back then how to work with this kind of hardware. It was pretty new. Parker Hannifin built airplane parts, and now we were building parts for the space program. They sound similar, but the requirements are so much more critical in the space program. It took a lot more precision to accomplish. And I think we all felt pretty good about you designed a component, you got it through the test program, made you feel pretty good that you got something worthwhile accomplished. The big thing was leakage. And we had to design valves that didn't leak. And to do that, you have to weld them shut. And the problem with welding them shut is if they have a problem and don't work, you got to fix them. So you have to design it so it can be cut apart, fixed, put back together again, and re-welded. That was a pretty good trick. So we had some pretty experienced engineers that designed those kinds of joints, and more than that, we had technicians and welders that were expert in the field. We thought we were big shots because we were using electron beam welding, and that was a really expensive process. It required very complex, expensive machinery to do that. And it's all you weld in a vacuum, basically, so you have to have a big chamber that you could pull a vacuum on and do the welding inside the chamber. They invested a lot of money in the program to develop the facilities and the hardware to do the job. I don't think we had any of that in this company before that time.
Well, I mean, there was a lot of attention on the Apollo 11, obviously. That we had brought televisions into our cafeterias. Everyone was watching the televisions. I think the landing was somewhere around noontime here in California. I think we forget, it was probably 7 or 8 hours after that they actually stepped off of the thing to step on the moon. So that most people were probably home at that time. So you watched it both here, the landing here, but the walking was probably more like at home. So excitement, and the world was glued to that. Not just the United States, but the world was glued to it. And every place you saw repeats of exactly that. It was exciting beyond belief.
That part of the program, very, very intense, because we didn't really know when you start to put this stuff into space. And the landing on the moon, that was the very, very first ever attempt at something like that. And you think about it today, well, how did we get that lunar module off the Apollo vehicle and down to the moon and then back up again? You wouldn't think, well, I don't think that's possible.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Wally, say something. I'm speechless.
I'm just trying to hold on to my breath. That is really something. Whew. What?
We're going to be busy for a minute. After I'm on, take care of the big. I'll get this back prepared.
Everyone wondered what Neil Armstrong's first words would be. This is Tranquility Base.
Very smooth touchdown.
Very smooth touchdown. I don't believe it yet. Tranquility Base. And the Eagle has landed.
We are now 106 hours, 27 minutes into the mission of Apollo 11. And some 15 minutes ago, from Tranquility Base, the lunar module resting on the moon's surface, Commander Neil Armstrong radioed he was beginning preparations for EVA. EVA standing for Extravehicular Activity, or to put it more simply, the moon walk.
It's one small step for man, one giant leap for mankind.
Armstrong is standing on the surface of the moon. 38-year-old American. On this July 20th, 1969.
Unofficial time on the first step, 109.2420.
A lot of the success of the program, the technology obviously was there, but there was an amazing logistics part of it. To bring all of these pieces and parts from all over the country and different people with all kinds of reliability and redundancy to make sure it happens. That was the real art of this thing, was the management thing that happened to bring everything together to make it work.
This is the crew of Apollo 13. Wish everybody there a nice evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening at Odyssey. Good night.
13, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks.
Okay, stand by. Guys, look at your O2 quantities and see if you see a big change. Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
When Apollo 13 had the explosion, it wasn't long after that actually happened that Parker Hannifin was contacted, because they figured out that one of the oxygen tanks on the Apollo vehicle blew up. They lost half the oxygen. They might have a problem with having enough oxygen supply to get back to Earth. And part of the analysis of that was by asking Parker to help them figure out, with the components that we provided, how do we maximize that oxygen capacity. But it's interesting from the standpoint that the Apollo vehicle had a filter to take this carbon dioxide out of the air, and the lunar module had a similar filter, but it was a smaller size. And when the accident happened on Apollo 13, then they discovered that, well, the filter from the Apollo system wouldn't fit in the LEM system, but they already had made the decision to use the lunar module as the vehicle to go back to Earth in. So all of the environmental stuff had to be jury-rigged so that it could be done from the lunar module side. And that meant that they had to take filter assemblies from the Apollo and put them into the lunar module system with duct tape and stuff. So one of the things they wanted to do was to evaluate the thing called the oxygen control assembly, which is a component that we built for Apollo, and just determine whether it was going to be able to work satisfactorily in these conditions that it was never tested for. So that's what the remote test site facility was used for, because we wanted to test it with oxygen. You can't do that in the standard laboratory environment here in this facility. So we put the team together. I think there was about 10 people that went out to this test facility, mostly technicians, that built the facility that needed a requirement to make that valve do what it had to do. We provided the data back to the people in the office, and through some magic, we got the answer to NASA that they were looking for. That probably was the key to the whole trip that made that success, that vehicle a success coming back home. I can't imagine it was going to happen, but it did. The regulator was designed to reduce 3,000 psi oxygen down to 1,000 psi to fill the backpacks that the astronauts used to go onto the moon. So that's its main function. But as part of the trip that was required to come back to Earth, we had to use all the oxygen, all the way down from 3,000 psi down to as low as it could go. And they wanted to know that when they reduced these flow rates, whether our regulator was going to not do something strange and not allow that to happen. I mean, you think about how a regulator works, and it should have been fine, because you're just reducing the flow rate. You might not have as good a control, but it does work properly. And we proved through testing that it could be done, and in fact, obviously it was done. From my standpoint, I didn't realize the complexity of what we were trying to do, or the implications of what we were trying to do, until it was almost all over, and we said, wow, we really can participate into something that is a life-saving situation. And it didn't hit home until we actually got done with our test program, for me anyway.
But these tests were run over and over again. That in the beginning, it didn't appear that we could actually have enough oxygen left to allow the astronauts not only to live, but you also need it for electricity and power and temperature and all that stuff. So it was important that we could dissipate this oxygen at 1,000 psi regulator down to a few psi, and that's not always easy to do that. And so we had to run test after test after test to verify that we could do it. And many of the tests failed. They said, we can't do it. So the guys kept working and working and working, and finally got to the point where they could actually have enough oxygen left to survive. So our part was very critical to the survival of this mission. And so we should be very proud of that accomplishment.
In those days, the telephone was critical. Even within the facility, everything was done by telephone. You didn't have portable devices to deal with. You used the telephone.
Not just the technicians, but the engineers, design engineers, and analytical engineers, running all kinds of analysis to make sure it worked, and then to verify it in the lab. So it was a very comprehensive effort by a whole team of people. Over a 2-day period we're talking about. And not only our stuff, there were other developers and contractors who are doing the similar thing. It was an effort to make sure they get home.
We did work around the clock, but it was only 2 days. So everybody was just so keyed up and doing everything they could possibly do to help get this answer that we wanted. I don't think anybody realized that they weren't sleeping very much for those 2 days. They were just so intense on making this happen. And we did it.
When they finally returned, there was absolute hysteria almost, so overexcitement of how great it was, not only for them to come back, but to know that we played a critical role in it. So it was very, very important. And it wasn't shortly after that the astronauts visited our facilities to express their thanks for what we did too. And in those days, the astronauts were like the cowboys of the Wild West. I mean, they were heroes. And you'd take them on a tour through the shop, and you go to the machine shop, there'd be banners on the wall. welcome Buzz, welcome Fred Hayes in this particular case on 13. I mean, that was the atmosphere. And we were, of course, proud of what we did to make this happen successfully. At this time, Parker Aerospace was on Century Boulevard at LA Airport. We had 13 acres there. We wanted to expand. Marriott wanted a hotel. The Marriott Hotel Company and Parker went into agreement. We took our 13 acres, essentially leveled the buildings. Marriott bought 75 acres for us in Irvine, built 4 or 5 buildings, and we flip-flopped property for a tax benefit. So we had a number of astronaut visits before, after, you know, Werner von Braun was here. So there's all kinds of stuff in the past. So a lot of interaction between the head NASA people and astronauts were here.
They just were very appreciative about what we had done for them. And I was so starstruck, I don't think I know that I said anything. I just was listening to what they had to say. But I don't think that it really sunk in as to what we had done until the papers came out and you got to read articles about what had happened. And, oh, you were involved in that. Oh, you did that. Oh, that's pretty cool.
Feels good. 20 feet. Going down at 2. 10 feet. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Okay, Parker valves.
Later, obviously after the Apollo, which was exciting, this led to the shuttle program, which Parker was extremely involved in. Parker provided many, many parts of the space shuttle. We made large 17-inch disconnects. So realize you're flowing liquid oxygen, liquid hydrogen through a 17-inch line. It's equivalent to like emptying a swimming pool in like 1 second. I was invited to Johnson Space Center to receive a public service award on behalf of Parker, what we did for Parker. Monstrous auditorium. They put us in the second row, and there were other people too receiving awards. Administrator at NASA gets up on the stage and says, "Would all those people that have left the Earth's atmosphere please stand up?" The first row stood up. We got the meaning of what it was. The astronauts were here to honor us for the products that we made to make this experimental program such a successful thing and to keep them safe. NASA was always good about trying to honor their suppliers, the people who participated. Apollo program, they had this thing called the Silver Snoopy Award. It was a little Snoopy, and that was given to people or organizations, primarily people, for their special over and above what they did. And we had a number of our people that received those. They get nominated by our contractors, our prime contractors, the people, and that's quite an award and quite an honor to get, and it's always given to somebody by an astronaut. So there's the meaning again, the significance of the program.